Level 1. Your device and home network. The bedroom bubble. At the very bottom, you control a tiny piece of the internet, your own devices, and your home network. This is your personal bubble where you're actually in charge, but it ends the moment your data leaves your house. Your home network is called a LAN, which stands for Local Area Network. It includes your phone, laptop, gaming console, smart TV, and any other device connected to your Wi-Fi router. The router is the boss of this little kingdom. It assigns each device a local IP address, usually something like 192.168.1.5 or 192.168.0.12. These addresses only work inside your house. They're like room numbers in a hotel, useful inside the building but meaningless outside. Here's what you actually control at level 1. You can change your Wi-Fi name and password. You can block specific devices from connecting. You can set up parental controls to limit what your kids access. You can even prioritize which devices get faster speeds, like making sure your work computer gets priority over your teenager's TikTok machine. Between your router and the outside internet sits your modem. Think of the modem as a translator. Your router speaks home network language, and the modem speaks internet provider language. If you have cable, fiber, or DSL internet, the modem converts the signals so your router can understand them and pass data back and forth. But here's the reality check. Your power stops at your front door. Once your data leaves the modem and enters your internet provider's network, you have zero control over where it goes, how fast it travels, or who can see it. You're just a tiny endpoint on a massive global system. Level 1. People think they control the internet because they can change their Wi-Fi password or restart their router when Netflix buffers. They don't realize they're standing on the very bottom rung of a 7-layer control structure. Your home network is an island, and you're the mayor of that island. But the ocean around you, that's controlled by much bigger players, and we're about to meet them. Level 2. Your ISP, the gatekeeper. Your internet service provider is the first real control layer above you. Companies like Comcast, Verizon, AT&T in the US, BT in the UK, Orange in France, Deutsche Telekom in Germany, or TM in Italy. These are the gatekeepers, and you have to go through them to reach the internet. Your ISP controls what's called the last mile, the physical connection from their network to your home. That could be a cable line, fiber optic, old copper phone lines, or even wireless signals. They own that connection, and they decide the rules for it. Here's what your ISP controls. They decide how fast your internet is, that speed you're paying for, 100 megabits, 500 megabits, a gigabit. That's a limit they set. They also control how much data you can use before they throttle your speed or charge you extra. In some countries, ISPs have data caps, where after you use a certain amount, they slow you down dramatically. Your ISP also assigns your public IP address. Unlike your local IP that only works in your house, this public IP is how the rest of the internet identifies your home. Every website you visit sees this IP address. Your ISP can change it, track it, and log which websites you connect to. In many countries, they're legally required to keep these logs for months or even years. ISPs make the first set of routing decisions for your data. When you load a website, your request goes to your ISP's network first. Their routers look at where you're trying to go and decide which path to send your data down. If their network is congested, your traffic slows down. If they have a bad connection to certain parts of the internet, your experience suffers. In some places, ISPs can also block websites. If the government orders them to block certain content, they do it at this level. If they want to slow down specific services like streaming video or file sharing, they can throttle that traffic selectively. You might not even know what's happening. But here's the limit. Your ISP only controls their own network and your connection to it. Once your data leaves their network and enters the wider internet, they're not in charge anymore. Bigger networks take over. Level 3. Tier 1. Backbone providers, the highway owners. Now we move into long-distance territory. Tier 1 backbone providers. These are the companies that own huge chunks of the internet's physical highways across countries and oceans. Names like Lumen, formerly Level 3, AT&T, NNT, and Telia Carrier sit in this category. A Tier 1 network is special because it can reach every other part of the internet without paying anyone else for access. It has massive fiber cables crossing continents, undersea cables connecting regions like Europe to North America or Asia, huge router hubs in major cities that handle insane amounts of traffic. When your data needs to go far, like from your country to a server on another continent, it almost certainly rides on fiber owned or operated by one of these Tier 1s. Your ISP connects upstream to one or more of these providers. That's how small local islands plug into the global ocean. Here's what Tier 1 providers control: the physical routes your data can take over long distances, how they interconnect with other large networks, commercial agreements about who peers for free and who pays for transit. If a Tier 1 provider has a dispute with another big network and cuts off peering, traffic between their customers can get slower or even temporarily break until routes are adjusted. That's real power. They can't turn off the internet, but they can make big parts of it work badly badly for certain paths. However, even they don't control everything. Each Tier 1 only runs its own network. There isn't one single master backbone owner. Instead, there's a small club of huge networks that all interconnect with each other. If one fails or misbehaves, traffic can often be rerouted through others. That's the key pattern of the internet. Big power, but still shared. So at level 3, control looks like this. They don't decide what you're allowed to see, but they do decide which roads your data can take to get there, and how fast and reliable those roads are. Level 4, Internet Exchange Points, the connection hubs. Internet Exchange Points, or IXPS, are the neutral meeting grounds where different networks physically connect to exchange traffic. They don't own the internet, but they're the glue that holds it together efficiently. An IXP is usually a building or data center campus where hundreds of different networks show up and plug in. ISPs, content providers like Google and Netflix, cloud companies like Amazon and Microsoft, universities, and even smaller regional networks all connect at IXPs. They run cables into a central switching infrastructure, and from there, they can exchange traffic directly with each other. Here's why IXPs matter so much. Without them, every network would need to negotiate and pay for connections with every other network individually. That would be a nightmare. Instead, networks go to an IXP, pay a membership or port fee, and suddenly they can peer with dozens or hundreds of other networks all in one place. This has huge benefits. Local traffic stays local instead of being routed halfway around the world. A user in Germany trying to reach a German website doesn't have their data bounce through the US. If both networks connect at the same German IXP, costs drop because networks aren't paying expensive transit fees for traffic. They can exchange directly, and speeds improve because shorter paths mean lower latency. IXPS also make the internet more resilient. If one path between networks goes down, traffic can reroute through different IXPS or different peering connections. The more interconnection points exist, the harder it is for any single failure to break connectivity. But IXPs don't make decisions about what traffic is allowed or where it goes. They provide the physical switching infrastructure and the neutral space, but the individual networks decide their own routing policies and what they'll accept from whom. Think of an IXP like an airport. It provides the runways and terminals, but the airlines decide which routes to fly and which passengers to carry. So level 4 control is about facilitation, not domination. IXPs make the internet work better and cheaper, but they don't rule it. They're enablers, not kings. Level 5, DNS and registries, the phone book keepers. Level 5 is where names meet numbers. The domain name system, DNS, is the internet's phone book. When you type a website name like google.com, DNS translates that into an IP address like 142.250.185.46 that networks can actually route to. Without DNS, you'd have to memorize IP addresses for every site you visit. At the very top of DNS sit the root servers. There are only 13 root server addresses worldwide, though each one is actually a cluster of many physical servers for redundancy. These root servers know where to find every top-level domain, things like .com, .org, .net, and country codes like .uk, .de, .it, .fr. When your computer needs to look up a domain, the query eventually traces back to these roots. ICANN, the Internet Corporation for Assigned Names and Numbers, coordinates this entire system. ICANN manages the DNS root zone, the master list of all top-level domains. Which new top-level domains get approved, like .shop or .blog. Global IP address allocation through IANA, the Internet Assigned Numbers Authority. Each top-level domain has a registry operator. VeriSign runs .com and .net. Public Interest Registry runs .org. Each country has its own registry for its country code. These registries maintain the master databases of who owns which domain names under their TLD. When you buy a domain, you go through a registrar like GoDaddy or Namecheap. The registrar talks to the registry to create your domain record. Then you point that domain at your web server using DNS records, and suddenly people can type your name and reach your site. Here's the control at this level. ICANN and registries can decide which domains exist and which don't. Revoke domains for policy violations or legal orders. Block certain names from being registered. But even this isn't total power. If DNS stopped working, people could still connect using IP addresses directly, and alternative DNS systems exist, though they're not widely used. This layer controls naming and addressing, which is huge, but it's not the same as controlling the network itself. Level 6, standards organizations, the rulebook writers. Level 6 is where the technical rules of how the internet actually works get decided. These aren't companies or governments. They're international standards, bodies, and technical communities that write the rulebooks everyone follows. The big players here are the IETF, W3C, and IEEE. The Internet Engineering Task Force, IETF, designs and maintains the core protocols that make the internet function. TCP and IP, the fundamental protocols for sending data across networks, came from the IETF. HTTP, the protocol your browser uses to load websites, came from the IETF. Email protocols, routing protocols, security standards like TLS that encrypt your connections, all IETF work. The World Wide Web Consortium, W3C, focuses on web standards specifically. HTML, the language that structures every web page, is a W3C standard. CSS, which styles those pages, comes from W3C. Web accessibility guidelines, video formats, and countless other technologies are defined here. The Institute of Electrical and Electronics Engineers, IEEE, handles hardware-level standards. Wi-Fi, officially called 802.11, is an IEEE standard. Ethernet, the wired networking standard, is IEEE 802.3. These specs define how devices physically communicate at the lowest levels. Here's the power these organizations have. When they publish a standard, that standard becomes the language the internet speaks. If you want your device, your software, or your network to work with everyone else's, you follow these standards. Manufacturers build hardware to these specs. Developers write software using these protocols. It's not legally enforced, but it's practically mandatory because compatibility depends on it. However, their control is technical, not political. They decide how things work, not who gets to use them or what content is allowed. They write the grammar of the internet's language, but they don't control what people say with it. And again, no single organization rules everything. The IETF handles network protocols, W3C handles web standards, IEEE handles hardware standards, and dozens of other bodies manage different pieces. It's coordinated, but distributed. If one standards body made a terrible decision, alternatives could emerge, though switching costs would be enormous. Level 7. Internet Governance. The global coordination layer. Level 7 is the governance layer, where long-term policy decisions about the internet's future get made. This is where ICANN's oversight, regional registries, governments, and multi-stakeholder committees all come together. And here's the twist. Nobody here has total control either. The key players at this level include ICANN's multi-stakeholder model, where governments, private companies, technical experts, civil society groups, and individual users all have a voice in policy discussions. It's intentionally designed so no single group dominates. Decisions come from negotiation and rough consensus, not top-down authority. Then there are the 5 regional internet registries, or RIRs, ARIN for North America, RIPENCC for Europe and the Middle East, APNIC for Asia Pacific, LACNIC for Latin America, and AFRINIC for Africa. These organizations allocate IP address blocks to ISPs and large organizations in their regions. They follow policies developed through bottom-up community processes, where network operators, businesses, and technical experts propose and debate rules. Governments participate through forums like the Internet Governance Forum and national regulatory agencies, but they don't unilaterally control the global internet. Some countries impose local restrictions through their ISPs, but they can't dictate how the rest of the world's internet operates. This layer handles critical questions like who gets which IP address ranges, how new top-level domains get approved, what policies govern domain ownership transfers, and how to balance privacy, security, and freedom online. But every decision involves compromises between competing interests. Here's the surprising truth that defines the entire internet. No single entity controls the whole thing. Not governments, not corporations, not technical bodies. The internet is distributed by design. Your home network, your ISP, backbone providers, IXPS, DNS registries, standards organizations, and governance groups all control their own piece. And the system only works because they cooperate. That's both the internet's greatest strength and its biggest vulnerability. It's resilient because there's no single point of failure, but it's also fragile because cooperation can break down. Now go watch this next one. I guarantee you'll disagree with at least 3 of my rankings on the 7 levels of internet.